I'm here this morning to talk about developing accurate costs to illustrate bridge preservation benefits. That in order to have a good and effective and preservation program that the upper management and our higher leaders are going to support, we have to be able to show that it is cost effective. One thing that I would like to keep you in mind, that you would keep in mind, is that the word developing is up there. This is a process. We're not done. We feel like we've barely started, but I'm going to share with you some of the things that we have talked about and are planning to implement along with this. Bridge preservation is doing our best to cost effectively keep our bridges in good condition. We know that that it begins with design and construction, and as was mentioned, George Connor yesterday, or the day before, I guess it was now, talked about design and how critical that is, but it's a period of time and then they hand it off. And then they construct it, and again, very critical. We've talked a lot about construction and how important good construction is to anything. But again, they construct it and they hand it off. Then we get it, and we get to preserve it, maintain it, and rehabilitate that bridge for the life of, hopefully, a really long life. But it's a long time. The right action, the right cost, and the right time, that we want to do those actions to keep the bridge in good condition. We need to help define that. Actions, what we're going to do, the benefits of those actions, the costs for those actions, and we need to be realistic about the costs. And I guess that is really that is the gist of my presentation, is that we need to have accurate costs for what we're really going to do. We need to be able to include all of the things that need to be included and be able to model that. And I think that when we do that, we are going to see the benefit. We need accurate data input. The bottom line is, if we do not have good bridge data, inspection, condition information, we aren't going to get anywhere. We need really good, reliable information. And then we need to work with deterioration modeling, deterioration rates. Then we can work with the actions, benefits, and again, the costs. So we'll talk just a little bit about North Dakota. Now, I know that, in North Dakota, we have a total of 1,725 structures that we maintain on our state system. That includes about 720 bridges. Most of the bridges are pretty basic, the basic designs. We've got pre-stressed concrete, reinforced concrete, steel, and we have a few trusses remaining, not many. And we do have one post-tension segmental box, happens to be the longest bridge in North Dakota, and there's a picture of it there. But we also have over 1,000 other structures. Now that does include smaller boxes, but that includes all of our box culverts and any structural plate pipes that we have that are greater than 8 feet in diameter. How many of you have fewer bridges than this? Is there anyone out there that maintains? Okay, we have, so most of you, I'm guessing, have, okay, a couple. There you go. So your local agency, so yeah, okay. I'm sure that most of you have more than that. Several of you probably have, an order of magnitude more than that. Because we have a relatively small number of bridges, we've been able to maintain those bridges relatively well and manage those bridges with a bridge management system without fully utilizing a bridge management system. It's painful at times, but I mean, we kind of get by. What do we do as far as bridge preservation? We have a maintenance manual that includes the maintenance actions that are done. Almost all of the maintenance work that is done by our maintenance crews within our districts. We do not have, though, any dedicated maintenance crews. So all of the bridge crews that we have, the maintenance crews that we have, do all of the different work that needs to be done by maintenance, from plowing snow to mowing the ditches to fixing anything, potholes on the pavement. It all gets done by them. We have 8 different districts. The abilities and the training in each of the districts varies, partly by, you know, how much training they've had, what their other capabilities are. But the one big thing is that all of their work is prioritized by the districts. We are not able to do that. So we want to make sure that we can define those actions. We have them defined in the maintenance manual, but we need to get those into the bridge management system. We also need to quantify benefits and develop costs for that. And again, realistic costs. Our rehabilitation projects are primarily done under contract. Larger projects, deck overlays, replacements, pier and abutment work. We have done a little bit of that internally, but most of that is done by contract. And again, we need to quantify the benefits and determine realistic and accurate costs for that work. It goes to where are we with our bridge management, and how can we move forward? Well, where we have been. We, prior to 95, used a mainframe for bridge data inspection and reporting. In 95, 96, we began using Pontus for element inspection, and yes, we did begin element inspection at that time, but we continued to use the mainframe for all of our reporting, data storage, and everything else. In 2009, we transitioned to using Pontus for all of our bridge management. Currently, we upgraded to the AstroWare BRM 5.2.3 in 2017. We use that program almost exclusively for everything that we do with bridge management. We don't have a lot of, I've talked to several states, and a lot of them have an additional program to help with this or that different aspect of bridge management. The only thing that we really do have is we have a very simple in-house developed inspection app. And really the reason that they developed that was because they were having a really difficult time reading the handwriting in the inspections and decided we needed to do a little bit better. So we developed something simple for that. But other than that, we use it for everything. Right now, we are managing our bridges using data from the BRM system. We use the data, but we don't use the system, maybe. Where do we want to be? We want to use that system for long-term planning, for deterioration modeling. We want to be able to let it help recommend preservation and rehabilitation work, optimize costs. You know, we know that the capabilities are there. We just need to get it there, because really, in order for it to be an effective system, we need to let it do more of the work and we do less of the work, right? It goes without saying that any of you in here that are involved in it, you can never take the human component out of that. Your system's never going to manage everything for you, but the more that we can get it to do and do well, the better off that we're going to be. In order to do that, we need to accurately describe within the system the bridge actions that we already know that we do. Any system, well, let me say it this way, BRM has stuff that is built in, and it has a lot of actions and things, but if there are things that aren't what you're doing in your state, they're really not relevant. So we need to, though, then quantify the costs and the benefits of those actions. We need to define the timing, and I'm not going to go into that a lot. It needs to be defined in there in order for it to do a good analysis. And again, we want to incorporate all of that into our BMS. So we're moving forward. We did training in October of 2017. We had a 3-day training in-house, and it was wonderful, and I learned a ton, and in turn learned how much I don't know and how much more I have to learn. Most of you, if you are familiar with BRM, are going to be familiar with this pyramid. It basically starts at the bottom, like I talked about. with and I don't expect you can probably read that much. I've got a bigger picture coming up, but we basically start with inspection, and we have some different things that we need to define, our utility costs and stuff for basically the values for our bridges and some things like that, and refining deterioration rates. But then we get to defining actions and benefits. Can you read that any better? So basically, when we get to, this is the base of our pyramid, but when we get here, we're talking about actions and benefits. And this is, specifically related to BRM, but it also, any bridge management system that you are using, in order for it to function well, you need to have these same things defined. This is really a big part. We can't move beyond this until we get this part figured out. So the first thing that we would do is define the benefits. Now again, these are all screen captures from the BRM, and if they may look familiar to some of you, but it's what we use, so that's what I've got. But benefits are basically the impacts to the structure as a result of an action. The revisions to the elements, we're going to increase the condition state or the NBI level of some of the elements based on the actions that we do. Again, we need to make sure that these are based on things that we really do. It's not going to do me any good if I have an action in here for something that I'm never going to do. It's useless. So we need to make sure that we can customize this to fit our program. This is another screenshot, and I'm not sure if you can read all of it, but basically the benefits in the program, you use this benefit to change elements, remove elements, replace elements, create protective systems, make changes to the data fields, NBI, scour, and risk factors. And you can change all of that within a benefit group. And then we need to look at the actions. The actions are the work that is done to the structure. Again, needs to be customized. So what we do is, we define an action, give it a little bit more descriptive if we want. This is the same screen, but it's the bottom part. It's linked to benefits. So what are the benefits that are linked to that specific action? Deferment rules. So if I replace a deck, I'm probably not going to want to do anything to that bridge deck for maybe 15 years, hopefully. So we can put rules in there that say, okay, we're not going to do anything for 10 to 15 years. And then we get to the costs. And again, this was on that previous slide. I'm just kind of blowing it up a little bit, so hopefully you can read it a little. When we get to costs, in order to put the costs in there, we have different options that we can use a general cost per deck area. So to replace a deck, this is probably not a bad way to do it. It's fairly simple, especially for us starting out. This is where we're going to start out, right? If you want to get more, if you want to get a little bit more, hone in on your costs a little bit better, you can actually define costs for all of the different units, any of the elements that are in there. So you would define all of the elements that could possibly be in your deck, and then it's going to pick out the ones. If it's got that, then it's going to replace it, and it's going to put a cost to that. The other thing that's really critical is the indirect costs. Unless you're able to get all of your costs into the deck area or the elements, you're going to end up with indirect costs. So that's going to give you a way to account for, mobilization, planning, design of your structure or, your project, whatever it is, traffic control. So you can enter that either as percentages or you can enter it as a flat cost. So for our maintenance work, again, we do different types of maintenance. It's typically done by in-house forces, and those total costs need to include material, labor, equipment, additional costs if contracted, but also additional costs even if we don't, like the traffic control, those sorts of things. If it's contracted, again, the other costs that we talked about. Again, rehabilitation work, those types of work, we typically do those under contract, and those costs need to either include overriding deck cost or unit cost for the elements. And again, some things are more readily correlated to the deck costs versus, if you're going to replace a pier, it's kind of challenging to relate that to your deck area, right? So then you can, for those, you would most likely use unit costs for the elements and have to come up with those costs. Then you, again, engineering, mobilization, other costs, environmental, design, all of that needs to be included. So here's where we come to a point where during our training we kind of went, what do we do with structure replacements? We have a number of different scenarios that we use, and we kind of limit it to this. Replacing a structure with a similar structure. So it meets basically all of the current standards, so we're going to just replace it with a similar structure. Replacing a bridge with a box culvert. I'm not sure how many of you would do this as a general, a widespread part of your program. But whenever possible, we're going to replace it with a box culvert. If we have a short bridge and we have very good waterway adequacy. It's not, obviously it's going to have to be over water or over a drainage channel. We're not going to do that over a bridge or a highway or something, right? But if we can at all do that, we will. It's just better, safer, easier maintenance. We also, at times, would replace it with a bigger, longer, wider bridge, right? And that's very often the case. And then we also have a term that you'll probably laugh at, but we call it replacing a mega bridge. Well, we don't have probably in some of your minds mega bridges, but we had to make a split somewhere, and that's a term that's been used in the department forever, so that's what we call it. But the more accurate we can get these costs, again, the better decisions that we're able to make about all of this. So our structural replacement, similar structure. We replace a culvert, almost always we're going to just model it as being replaced with a similar structure. Bridges that meet current standards. So the action would be replacing a structure. The cost, again, we can use a deck area cost. We can break it down. We also make sure that we include all of the indirect costs. Now that's really a challenge, right? Because how do you quantify all of that? And how much does it vary from bridge to bridge? And if any of you have great ideas about that, I'm really willing to listen because we're not there. We know we need to do it. We need to take that all into account. But sometimes those are really difficult to quantify. But the benefit then is to replace all of the elements. So we would basically be replacing everything. So in the benefits tab that we had, you would be replacing everything that's in there. For structure replacement, replacing with a box culvert, as I mentioned, here's where we kind of came up with something somewhat innovative, is that we basically, as far as when we got to the benefits, we removed all of the bridge elements except for the abutments. So then we replaced the abutments with a reinforced concrete culvert. And that basically doubles the length because we have two abutments. So it's basically going to say we're going to put a box culvert in that's twice as long. We use a cost for that box culvert. And again, we've got to make sure that we get all the costs in there, but we end up with the right element at the end. Again, this is just basically what I said. This is the steps to go through, removing the elements and replacing the elements. And then replacing with a longer, wider, we would look at the appropriate factors, take the appropriate actions, our costs and benefits, and our mega bridges. So yes, over 20,000 square feet. Okay, but we know that these costs, the reason that we break this out is that when you're over a waterway, when you're over, when you have these longer spans, the costs are, they're in a different range. We have a lot more environmental documents that we end up having to do. So these really go into, and this is what our history has shown us, that these can be double the cost of a smaller bridge per square foot. Basically, then again, we would replace all of the elements. Deriving the unit costs, challenging, right? Because One of the big things is how do you convert bid costs to unit costs for all of these elements, if you're looking at it that way. You're bidding in cubic yards of concrete, you're replacing square foot of deck, and some of those things that are really challenging. And again, we have to work on that. Really welcome any questions. By the way, while you're going around, this is one of the bridges that we have rehabbed. It's one of the trusses that actually spans the Red River, so we share this with MnDOT, but.
How much of a pain was it to go to BRM 523?
Honestly, from my perspective, it really wasn't painful. The IT person would probably tell you a little bit different in that actual switchover process. There were some things that we did need to do, but really not, from my perspective, really not bad at all. And it's really the format is, compared to some of the older formats, the format of the actual screen is really a lot nicer.
Mm-hmm. What about upgrading to the next?
I'm told that 5.3 is out there,
Yeah.
and I'm told that they've made really very few changes that are going to cause, they say it's going to be really painless and that there's a lot more things that they've refined in there and kind of worked out some of the things. So we just got to talk our IT people into going to that step, but I don't think it's going to be too bad.
Just as a follow-up to going to 5.3, we went to 5.3 about 3 weeks ago at Kentucky and haven't seen any issues whatsoever. I think the best thing that we like about it is now whenever you click on an element, you don't have to wait. It automatically goes, all of your defects are there, and that saves, you wouldn't think about it, but that saves a lot of time when you're putting in your inspection data and you don't have to wait for that. And we also really like the new cross-section module that's part of it.
Excellent.
Going to 5.3 really wasn't that bad at all.
Excellent. So if I get any grief from my IT people, I'm having them call you, Erin, so.
Judy Tarwater with AASHTO, and one thing I'd like to say is that after the release of 5.3, the release that we're working on next, the next one that's going to come out, we're actually calling it our Patchable baseline release, and that what we're trying to do with this release is set it up to where all of the common DLLs are all packaged together in the build, so that as we go forward, hopefully a lot of the things that if there's a minor change to one particular piece of the program, you don't have to do a complete reinstall. You can just do a patch, just to patch the certain DLLs that were affected. So that's one thing that we've heard from the user community, is that a lot of times it's difficult for the bridge guys in the DOT to go to the next version because they have to make an IT project, and sometimes IT is outsourced, and it's just a lot more work for them. So we're trying to set it up to where, unless it's something really, really major, not make you do a complete reinstall, but rather just a patch. Excellent. So that it's easier for you.
Great. Very good. Great.
Well, let's give Nancy a thank you and appreciate
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.